Good morning, everyone. Today I'm going to give a presentation for my term project report. My term project report is downlink multicast in OFDM network using different resource allocation. Here is the overview of my presentation. In the first part, I will introduce some basic knowledge and background knowledge in this field. And in the problem formulation part, I will explain why this problem comes into the sight of scholars and researchers. In the third part is motivation part. In this part, I will give the motivation of research for my term project. In the little review part, I will explain and describe what others have contributed to this field. And then in the next section, I will describe and explain the most widely adopted resource allocation strategies, and then the computer program demo, and then I will discuss the performance of the previously described resource allocation strategies. In the following part, I will give some conclusions and thoughts for the resource allocation strategies. My project presents effective dynamic resource allocation schemes with different resource allocation algorithms for multimedia services in downlink multicast orthogonal frequency division multiplexing mobile cellular service. Performance of different resource allocation algorithms for downlink multicast in OFDM network is thoroughly analyzed and compared. The study is focused on performance in terms of quality of service, spectrum efficiency, system throughput, interference suppression, and power saving. Several widely adapted resource allocation algorithms are simulated by computer program to evaluate the effectiveness in real-world runtime conditions. Here is the problem formulation part. Let's introduce some basic knowledge in this field. A cellular system is a wireless network distributed over a lot of geographic areas, each served at least one fixed location transceiver. Orthogonal frequency division multiplexing is a method of encoding digital data on multiple carrier frequencies. Resource allocation is an important topic in the research field. It is related to designing and build efficient and reliable cellular system. The major challenge coming from the conflicts between limited wireless communication resource and the increasing demand of wireless communication service has been a bottleneck for today's development of communication network. In addition, as wireless network signals have the tendency to path loss, feeding interference, and other issues, it is necessary to develop an efficient and reliable resource allocation strategy for interference suppression, system throughput, and power saving. Here in the literature review part, I will describe what others have contributed to resource allocation research in a brief way. First, a resource allocation resource based on time-varying gradient has been proposed by Jianwei Huang and his colleagues. In his research, the presented resource allocation strategy not only determined which user to be scheduled, but also decided the specific allocation of physical layer resource, such as transmission power. David and his colleagues have presented dynamic downlink or FDM resource allocation schemes to achieve high quality of service and system spectral efficiency. Best subcarrier allocation algorithm has been proposed for real-time voice and extended to delay tolerance services to improve service system performance. The authors have utilized interference suppression techniques to assist the resource allocation process. The presented dynamic resource allocation strategy with interference suppression techniques proves to be efficient for downlink multicasting or FDM system in terms of both real-time service and delay tolerance service. Hui Liu and his colleagues investigate resource allocation for multi-user or FDM. They proposed an equal rate allocation to the subcarriers assigned to one user. This resulted a small signal overhead and a low complexity method of multi-user resource allocation. Asymptotic limits were given for the instantaneous perceivable performance loss of the proposed strategy in case of single-user resource allocation. With this strategy, a heuristic method was designed to maximize the weighted sum rate subject to the minimum rate constraint and the power limit. Simulation demonstrated that the proposed strategy has better performance than water filling when channel was rapid. This method gave a near optimal subcarrier assignment to resource allocation problems with water filling applied. This implies that the method can be used for other resource allocation problems in multi-carrier system with small modifications. And let's discuss the most widely adopted resource allocation strategies. They are equal rate resource allocation strategy, gradient-based resource allocation strategy, and minimizing power consumption resource allocation strategy. Equal rate resource allocation strategy is good at suppress larger signaling overhead, which leads to less transmission efficiency compared to the water filling strategy. To achieve the goal, the algorithm dynamically assigns the same rate to each subcarrier per user. Gradient-based resource allocation strategy is motivated where a gradient-based scheduling algorithm is used for a system that multiplexes users in a time slot via code division multi-exercise. One of the famous power-saving schemes is sleep model. Mobile stations shut down their receiving function for certain interval when they have no packet to send or receive. Here is a discussion of the different resource allocation strategy. For equal rate resource allocation strategy, it proposed an equal rate allocation to the subcarriers assigned to one user. This resulted in a small signaling overhead and a low complexity method of multi-users resource allocation. Asymptotic limits were given for the instantaneous perceivable performance loss of proposed strategy in case of single-user resource allocation. With this strategy, a heuristic method was designed to maximize the weighted sum rate subject to the minimum rate constraint and the power limit. Simulations demonstrated that the proposed strategy has a better performance than water filling when channels vary rapidly. This method gave a near-optimal subcarrier assignment to resource allocation problems with water filling applied. This implies that our method can be used for other resource allocation problems in multi-carrier systems with small modification. For gradient-based resource, we have considered the problem of gradient-based scheduling and resource allocation for a downlink or FDM system, which essentially reduces to solving a convex optimization problem in each time slot. We studied this problem for a model that accommodates various choices for user utility functions, different sub-channelization techniques, and self-noise due to the imperfect channel estimates or phase noise. Using duality theory, we first gave an optimal algorithm for solving a relaxed version of this problem in which users can timeshare each sub-channel. This involves finding a maximum of a per user metric for each subchannel and a one-dimensional search of an optimal dual variable. More interestingly, this algorithm typically automatically uses an integer carrier allocation. To enforce such a constraint on all tones, we further proposed an algorithm that picks an integer carrier allocation and optimizes the power allocation accordingly. The numerical performance of this algorithm is almost identical to the optimal solution of the relaxed problem. Finally, we propose two even simpler suboptimal algorithms that only perform a single sort on each of the tones and avoid any iterative calculations. Simulations show that the suboptimal algorithm achieves close to optimal performance under a wide range of scenarios, and the performance gap widens when per user SNR constraints or channel estimation errors are considered. For minimizing power consumption resource allocation strategy, among the three strategies, multicasting services prefer resource allocation with power saving strategy. Resource allocation with other strategy give little gain because the effects of frequency selectivity is very small when multiple mobile stations exist and each mobile station experiences independently channel. Therefore, the average channel quality among MS does not depend on the resource region used for transmission. Here is our conclusion. For equal rate resource allocation strategy, this algorithm proposed an equal rate allocation to the subcarriers assigned to one user. This resulted in a small signaling overhead and a low complexity method of multiple user resource allocation. For gradient-based resource allocation strategy, we have considered the problem of gradient-based scheduling and resource allocation for downlink of FDM system, which essentially reduces to solving a convex optimization problem in each time slot. We studied this problem for a model that accommodates various choices for user utility functions, different sub-channelization techniques, and self-noise due to imperfect channel estimate or phase noise. For minimizing power resource allocation strategy, the previous sections introduced two strategies of resource allocation and show that it is efficient to take power saving strategy in case of multicasting. Optimal method is introduced as a resource allocation scheme based on this strategy, but it is not practical because of complexity. For real-time processing, suboptimal algorithm is then presented. The simulation results show that 20% of the total power consumption can be saved by these algorithms. In addition, proposed algorithm is shown to have almost the same performance and reduce the complexity remarkably. And thank you very much to Dr. Dapeng Wu, and a special thanks to Xin Li. Thank you very much, and my project will not finish without your help. Thank you.